The current date is October 6, 2025. NASA is silenced overnight as a federal shutdown erases updates from nearly every display. Similar to 3I, Atlas, only the third observed interstellar object barrels travel 30 million kilometers past Mars. The Sun blocks the view of Earth's telescopes. And now, when the solar system's most alien visitor is in its one and only close pass, America's eyes become dark. Only a handful of orbiters circling the red planet can record the comet's secrets before it vanishes forever. But as data leaks and fragments and official channels stay quiet, the world is left asking, what happened during the blackout? And what did we miss in those crucial moments? 15,000 NASA employees are sent home overnight. The agency's public voice, its newsrooms, websites, and social feeds go silent, replaced by a single static message. Interrupted operations, the first time in a long time. No live updates stream from mission control. No images appear from Mars or the Moon. No tweets break down the latest cosmic discovery. The order to shut down, driven by a Congress-wide appropriations lapse, draws a hard line between what is essential and everything else. Only a skeleton crew tasked with astronaut safety, planetary defense, and the clock remains intact. The rest, scientists, engineers, communicators, are locked out of their systems, which prevents distributing even standard status updates. Social media managers are caught between OMB directives, and mission leads watch as hard-won audiences vanish into nothingness. In the vacuum left by NASA's silence, rumor and speculation begin to fill the gaps. Official data pipelines freeze, and the world is left searching for any signal in the dark. 3I. Atlas is not simply a different comet. Discovered on July 1, 2025, this item bears the interstellar designation, a rare visitor, the third ever confirmed after 1I, Oumuamua, as well as 2I, Borisov. Its path through the solar system is strictly hyperbolic, a mathematical guarantee that it will never return. The trajectory is rapidly descending, skimming close to the ecliptic, setting astronomers abuzz from the moment its orbit was computed. By the time it neared Mars, projections left no doubt this was a once-in-a-lifetime encounter. The observation window would be measured in hours, not weeks. Every kilometer traveled by 3I Atlas was a kilometer farther from any future study. In contrast to periodic comets, there would be no second chance. Its nearest approach to Mars, about 30 million kilometers, offered the sharpest possible view before it vanished forever into interstellar space. The need to act was scientific. The unique opportunity ticked away, the clock relentless. On October 3rd, geometry, not politics, is what opens the door. As 3I Atlas sweeps past Mars at roughly 0 to astronomical units, or 30 million kilometers, the angle as seen between the Sun and the comet from Earth shrinks below 10. For ground-based telescopes, this is a hard limit. Most observatories refuse to risk their optics when a target skims so close to the Sun's glare. Even space telescopes in Earth orbit are compelled to withdraw, locked out by the same relentless geometry. The result, Earth's entire astronomical arsenal is effectively blinded for the length of the flyby. Only Mars, offset in its orbit by more than 40 degrees, provides a clear view. For a brief period of time, every data point, every image and spectral line must come from machines circling or crawling on the red planet. The scarcity is absolute. In the silence left by Earth's blackout, the burden of discovery shifts to Mars on its own 9 minutes. That is the length of the automated sky survey on Perseverance, October 2nd. Each frame time-stamped, each pixel scrutinized by mission software. In the middle of this sequence, a faint streak cuts across the Martian sky, moving at an angle and speed that defies ordinary explanation. Pixel-by-pixel analysis suggests a speed of close to 60 kilometers per second, precisely matching the projected path of 3I Atlas as it flew by Mars. This image does not originate from a NASA release. Instead, it comes to light in a private online forum for astronomy posted by Astromir, an amateur. She claims access through a back channel, sharing the raw, uncalibrated frame just hours after capture. Her message is blunt: If bureaucracy buries the truth, the public misses history in real time. The Post starts a storm. Debate erupts over authenticity, with skeptics probing for glitches, cosmic rays, or digital ghosts. But the numbers hold up under scrutiny. The streak's direction and timing are not random. If it is true, it is the first concrete proof of an interstellar object that Mars captured. If not, the world is on the lookout for a phantom. The only solution to the problem is corroboration from above. Mars orbiters must now hunt for the same signature before the cold trail begins. Mission teams across 3 continents scramble for a solution. With NASA's public support channels offline, European, Chinese, and Emirati controllers turn to encrypted chat rooms and backdoor Slack workspaces, digital lifelines designed for occasions like this. On October 2nd at 18:07 UTC, a tense cross-agency call ends with a single directive: repoint every available instrument at 3i Atlas, no matter the risk to routine schedules. The high-resolution axis of Mars Express's stereo camera swings off the surface. OMEGAS spectrometer is reprogrammed on the fly, and the XMR's trace gas orbiter switches from atmospheric sniffing to comet tracking. The UAE's HOPE orbiter slows its ultraviolet spectrograph, while Tianwen-1's imaging suite is redirected far from its usual patrol routes. Each maneuver pushes hardware and software beyond their tested limits, thermal modules squeezed, memory buffers flooded, automated scripts rewritten in real time. In the background, a private Slack channel nicknamed Mars Side Eyes becomes an improvised mission control. It's here that a last-minute software patch, shared by an ESA engineer, unlocks a critical pointing mode for Mars Express. Within hours, a multinational fleet is locked on target, capturing the only multi-instrument dataset of an interstellar visitor as the rest of the solar system stands blind. Mars orbits under the watch of a multinational fleet, each spacecraft tuned to a different window of the electromagnetic spectrum. Mars Express, operated by the European Space Agency, brings the high-resolution stereo camera for broad imaging and OMEGAS spectrometer for visible-to-infrared scans, ideal for mapping coma structure and hunting for chemical fingerprints in the dust. The XMR's trace gas orbiter, also from the ESA, splits light into thousands of wavelengths with its NOMAD and AX instruments, searching for rare gases and tracking the evolution of the emerald green coma. The United Arab Emirates HOPE orbiter shifts to ultraviolet, with EMUs and XE capturing the faint glow of carbon and oxygen emissions, while EMIR sweeps the infrared for thermal clues. China's Tianwen-1 pivots its Mi and OCOM imagers, providing multiband color snapshots and energetic particle readings to probe the plasma environment around the comet. Each instrument fills a spectral niche: visible, infrared, ultraviolet, plasma, layering perspectives that no single telescope could achieve. Together, these Mars-side eyes form a composite observatory, their overlapping fields and complementary sensors building the only complete dataset on this interstellar visitor. As it slips away from the red planet, an emerald haze blooms around 3i Atlas, dwarfing Mars itself. Over 700,000 kilometers across, the comet's coma glows with an intensity and color rarely seen in our solar system, a vivid, saturated green. Spectral scans from Mars orbiters reveal a chemistry dominated by carbon dioxide, not the water vapor or cyanide that usually paint a comet's shroud. Even after a recent coronal mass ejection, the coma holds steady, its glow undimmed, its plasma environment strangely calm. The numbers defy standard physics. Against all expectation, this interstellar visitor carries an envelope both vast and resilient, a cosmic signature that resists easy explanation. A dust tail should stream away from the sun, pushed by light and solar wind. Yet from Mars, 3i Atlas displays the opposite, a blade of dust pointing straight toward the glare. Early analysis from Mars Express and HOPE orbiter images suggests this anti-tail is built from grains hundreds of microns across, 10 times larger than typical comet dust. Standard models say such grains should quickly fall behind, not lead. Theorists scramble to explain how particles this heavy resist the sun's radiation pressure. Is it mineral makeup, cohesion, or something never seen before? Without calibrated data, the mystery only deepens. Raw data trickles through encrypted channels, but the full story is locked away. Archival releases delayed for months by agency protocol and blackout rules. As 3I Atlas slips into solar conjunction, only future missions like ESA SJUIC hold hope for new answers. Until then, every unexplained reading lingers, fueling a growing hunger for the next data drop. On October 1, 2025, NASA's public channels went silent just as 3I Atlas, only the third confirmed interstellar object, approached within 30 million kilometers of Mars. During this blackout, Earth-based telescopes lost sight of the comet, leaving Mars as the sole observation post. The Perseverance rover captured a 9-minute sky survey showing a streak at 60 kilometers per second, matching the comet's predicted path, though its authenticity remains under review. Mars orbiters from 4 nations executed emergency retargeting, gathering raw data that has surfaced only through unofficial leaks. Despite a severe solar storm, 3I Atlas displayed a stable, carbon dioxide-rich emerald coma over 700,000 kilometers wide and a sunward antitail of large dust grains, both defying current comet models. Months will pass before the full, calibrated datasets are released. Key questions, like the true nature of the Perseverance streak and the cause of the comet's anomalies, remain unresolved. As 3I Atlas slips behind the sun, the search for answers shifts to future missions. For now, the Mars blackout stands as a stark reminder. Sometimes the universe's most urgent mysteries arrive when our eyes are forced shut.